And have a seat. We'll get started here so we can stay on time. We don't want to miss our breaks and the meet and greet after this at 5 o'clock, so we'll get on through. My name is Brad Kizzort. I'm with Peraton Corporation and have been a member of the OMG for a long time, maybe 2005, somewhere around in that range. I want to welcome you to the first ever Space Specs Day. We've had Space Information Days in the past, but today we thought we'd do a little bit different with the panel discussions, bring in a lot of outside folks to sort of bring their perspective on the use of standards within the space industry. And I hope you enjoy it, and we hope to do some more of these in the future. So this Space Domain Task Force, as part of the Object Management Group, was founded, was chartered back in 2001, actually 2000. And since that time, we've published a number of specs that are used in industry, and I'll go through them here. Some of the speakers later will talk about those, and some of the panelists that will come up. But this is our start. We're doing this because we plan to publish a lot more. So starting from the lower left-hand corner, there's the XML telemetric and command exchange, which is an exchange format for command and telemetry databases. So the satellite manufacturer can communicate that information to an operations team. The satellite operations language meta model, which is a similar exchange format to communicate recommended operating procedures for a satellite. Command and control messaging specification, which is technically it's adopted and not published yet, but will be published soon, which is a messaging specification for use inside a control center as a loosely coupled integration technique for mission management software. The XUSP, which is the XCC U.S. government profile, is sort of a simplification of XCC, a subset to make it easier to implement on the vendors. The ground equipment monitor service, it's a protocol defining the protocol between the control center and the ground equipment, such as antennas and modems. I think that's 5. Then I have a slide that kind of puts it into context where these various parts are used. So you can see down in this section is a sort of an offline transfer of these operations artifacts that go from the satellite factory to an operations center, possibly to another operations center, or a cooperating one, or a tech refresh operating center. And then C2MS, which is a real-time specification. So it's within the control center itself, and gems between the control center and the ground equipment that communicates with the satellite. And then we have another one that we just issued an RFP for, and we have our letters. We have 5 letters of intent for the CubeSat system reference model. So we expect to be selecting between those submissions and hopefully published near the end of this year. We'll see how long it takes to get them in shape to be published. But that's why I've got the coming soon on that. That's really going from the mission design team to the satellite factory and the operations center. So it's really the mission definition for a satellite mission captured in SysML is the intent there. So all of these specifications, including the CSRM, even though it says CubeSat in the title, they have applicability to what I'll call big space, right? Big space is a space that many of us are already familiar with that have worked in the industry for a while. They're larger satellites, long lifetimes, mission profiles that are very long, so a satellite that lasts 15 years on orbit and is monitored for that length of time. NASA has one that is flying out to Pluto for 25 years, so it won't even actually conduct its mission until 25 years after the satellite was built. So like I said, this is big space. This is the slower moving space. And then what we're going to talk a lot today is what I'll call agile space. It is CubeSats, but it's more than CubeSats because it's a lot of smaller satellites, and really the concept is more that it's smaller satellites, shorter operational lives, with a rapid injection of technology into the on-orbit platform. So it really is more like agile software development. It's agile system development in space. And this space revolution is really the result of a tremendous drop in the cost of launching something into space, and the increasing the accessibility of space. This is a diagram showing one aspect of this cost drop. Right, this is the launch cost for a kilogram of payload to near Earth orbit and the various platforms that are there. Fortunately, you can't read it real well, but you can see that this is a logarithmic chart. So there's a 2 order of magnitude drop in the last 30 years within space, and projected further drops with newer technologies. So this is really, dropping the cost of a kilogram from over $85,000 to less than $1,000 with the Falcon Heavy. Now, so this is just one aspect of the cost drop. There are really a lot of things that are coming together at once that are making this possible, not just a drop in launch cost. As an example of the accessibility in space, right? We used to think about space in terms of NASA and these bigger programs, but the accessibility has gotten to the point that universities are launching CubeSats. There are some folks here from Montgomery Blair High School that are building a CubeSat and launching it. I don't know what their launch date is yet, but they actually have their webpage up and are seeking funding for a CubeSat mission here. And the other example I have that's also very timely on accessibility space is the Bearsheet mission, which actually launched February 22nd. So this is their mission timeline. It launched a little over 3 weeks ago. Wednesday of this week, it will reach the 400,000 kilometer orbit, which overlaps the moon orbit. So they'll be able to do lunar capture on a lunar orbit on April 4th, which is just a few weeks away, followed by a lunar landing on April 11th. And the unusual thing about that is that this is the first privately funded soft landing on the moon. Right? The all-in mission cost for this system was about $100 million. If you compare that to something like the Luna series that was done by the Soviet Union, which was probably a $4 to $5 billion project to do that, or we don't have figures on what China used to put a lander on the far side of the moon recently. But this is all privately funded and run by a nonprofit corporation. And in a few weeks, it may be the first successful soft landing on the moon by a private entity. So that's kind of my introduction of this is space, this is how it's changing, and how we expect it to change a lot more. So we'll move now